Hello everyone, so now we're going to move on to the final lesson of Unit-0, which is all about building effective messages for actors. So our little use case here is we're going to build some word count actors to help us analyze word count frequencies inside documents. So we're going to have at least one actor that does the processing, essentially sums up all the different frequencies of words, and another that does the retrieval of those words from some raw text document initially. So the first thing we need to do to really make this work is we need to develop a messaging protocol. Now I'll go ahead and highlight this on here before we type it out. This is typically the type of grammar you will see me use when we're defining messages, which is we're going to organize messages as an effects system. We typically have commands, which are requests to do something. These are like the raw inputs into an actor. Then we might potentially have, let's say, queries, which are a way of being able to fetch state that's happened inside our actor system somewhere. And the third and probably the most important type of message that we actually don't even use in this application, the third and most important type of message we usually have is an event. An event is a record of something actually happening. So events don't really get validated. They are a matter of fact inside the system. Now, this application is really simple, so it doesn't really use events all that much. We're going to see us use this a little bit more inside Unit 1. So for the time being, let's go ahead and jump into the code and start working on implementing these actors and this messaging protocol, and then we can round out Unit 0. Okay, so what we're going to start with here is we're going to create a brand new file. We'll call it messages, and I'm going to go ahead and nest my messages inside some static classes. We'll go ahead and do document commands right here. Let's go ahead and basically just type these out. Now, one other important thing you'll see me do in all of my modern code samples is I use record types almost exclusively for all of our messages and for all of our state objects as well. So in this case, we're going to go ahead and do a process document command. There we go. String document. Yeah, that seems fine. Let's see. We'll go ahead. Actually, I guess in the text of the application, we call this raw text. Fine. We'll do that just to make things seem copacetic. We'll go ahead and do another static class for counter commands. So this is for a different actor. So we're going to go ahead and do a public sealed record, count tokens, and I'll pass in an I read-only list, string tokens. And then I'll go ahead and do a public sealed record, expect no more tokens. Do that. Okay, so these commands are for the parsing actor, and these commands are for the totaling actor. So different commands for different parts of our application's domains. And then finally, we need to add some queries down here. Let me go ahead and do that real quick. Static class, counter queries. And we just need one for sealed record, fetch counts. And we're going to pass in a reference to an actor here. Yep, get that. And this will be the actor who should be notified. So this is a little thing we're doing differently. You saw us in the hello actor, if I pull that up real quick, use the reply to sender pattern for basically notifying an actor about some output type. This is a slightly different way of doing it, which is we include a specific actor reference that should be notified. Rather than replying on the sender property, which is always implicitly set when one actor messages another, we're going to explicitly set the recipient in the content of this message. So this is a really simple messaging protocol. It uses that same type of effects system we talked about earlier. We're just not using any events yet inside this application. Okay, so that's a pretty good starting point here. Now, one question you might have, and we do cover this a bit more in Unit 1, is how did I come up with any of these messages? Well, typically the process I use for this is a event-driven programming technique called event storming, where we try to model all of the events that can basically influence domain state changes inside our system. This application is really stupid and simple and is only using commands, so we haven't done anything quite that ornate yet. We have one command for processing a document and turning that into tokens, another for taking the tokens we found and sending that for counting, and then kind of like an end of file notification here, letting the counter know that, hey, we're done. All the tokens have been extracted. And then finally, we have some way of fetching those token counts by basically just doing request response of that actor. That's all that we have so far. So let's take a look real quick at the flow that we're imagining for actually messaging and interacting with these two actors we haven't gone and created yet. All right, so now we're back to the lesson content real quick, and I didn't really address this, so I'll make sure we do it now. Your message types should always be immutable. This makes it safe to broadcast the same message to multiple actors all running inside the same process. So the easiest way to guarantee immutability is to always make sure that any object that you declare yourself, any class you declare yourself, is always a record type. That will have some built-in immutability, which is very useful. The other thing is never pass around good old-fashioned collections. Always use either a read-only collection, which we did in this example, or use something like system.collections.immutable. This will go ahead and make sure that no one could do something like pass around immutable list, and actor A can add an item to it that actor B will then pick up, and this will create some undesirable side effects if you do it that way. So message types and state types should always be immutable. That's a really good hard and fast rule you should always follow when working with akka.net. Now the next thing we want to talk about real quick is our execution flow. We've defined our messages, so how are we imagining these actors interacting with each other? Well, first we have the client. This is really our program.cs here. It's going to go ahead and tell the ParserActor to process this document, including all the raw text that was in there. And then we're going to go ahead and tell the CounterActor, we want you to notify us about all of the tokens that you provided. And what's going to happen is this ParserActor is going to chunk tokens, distribute them to the CounterActor for tabulation. And then once we reach the end of this file, we're going to go ahead and let the CounterActor know to expect no more tokens. And once the CounterActor receives this message, it'll have tabulated everything. It can then send all of the counts back to the client. So what's interesting about this is that this design actually uses pipelining, where the ParserActor is working asynchronously to do token tabulation. The CounterActor is working asynchronously to actually sum up all those frequencies. And then finally, this client actor doesn't need to get a response back right away. We don't have to poll the CounterActor, in other words. The CounterActor will receive our fetch counts message and simply store a record of who we need to notify about the totals once we have them. This is one of the really big advantages of the actor model is we're not building stupid function call systems here. The actors can actually be pretty sophisticated about when they respond to messages. There's nothing that obligates me to respond right now. I'm going to choose to respond once I have all of the data that the client actually wants, which is going to be at the very end of the tabulation process. So bearing that in mind, let's go ahead and jump back into our code for the last time and actually implement all of this and then run our sample and see how well it does. All right, now we're going to go ahead and start by creating our CounterActor first, since I think that's probably the more complicated out of the two of them, just in terms of the sheer amount of code we have to write. The actual actor code will not be that complicated in the grand scheme of things. Now we've got our CounterActor. We'll go ahead and make this an untyped actor. Why not? Now I always like to make my classes sealed if I don't want anyone to inherit from them. Create our onReceive. Sure, that's fine. Next thing we'll do, just add a little bit of boilerplate. I'll go ahead and add my logging adapter. Why not? Go ahead and do log equals context.getLogger. There we go. And I guess a couple of other things I'll do real quick is I'll make it really easy for us to use those static message classes we created. So I'll go ahead and import my counter commands, and I'll go ahead and do my counter queries as well. So we're going to do using static, so that way I don't have to type out the full name here. I can just go ahead and basically use count tokens, expect no more tokens, all that stuff. So anyway, we're going to go ahead and do that. That looks pretty good. Now we need some data structures in order to actually allow this actor to run properly. The first is need a data structure for storing word count frequencies. All right, so this is exactly what we actually have in the Bootcamp documentation. We're going to go ahead and use a dictionary to store word counts, where this is going to be the term, this is going to be how frequently it appears. All right, looks pretty good to me. Next, we need to go ahead and need a flag to indicate that we are done counting. All right. And in the documentation, I think we call this done counting. So I'll go ahead and change that just to make sure we're consistent. That looks good. Next, need to store all of the actors who want to know about our counts before we're done counting. All right, now GitHub Copilot kind of did a bad here. The correct data structure to use for this is actually a hash set. The reason being is that ActorRefs are guaranteed to be unique by value. We want to go ahead and basically make sure that if we have, and I'll correct that as well, we want to make sure that if the same actor gets subscribed multiple times, it only gets one copy of the message. A hash set will naturally debounce that for us. So, okay, that looks pretty good. Next thing we need to do is we need to go ahead and add a switch statement for our message. And the first thing we're going to go ahead and take care of is we're going to go ahead and take a look at the, I guess, count tokens message type here. Do that. Go ahead and create a little case statement. And we'll go ahead and basically loop through for each var t in count tokens.tokens. Go ahead and simplify that. There we go. We'll try and add this value and set it to 1. Otherwise, we'll go ahead and increment it by 1 down below. That's sort of what we're doing here. This will help make sure all of our token counts are accurate. All right, that looks pretty good. Let's go ahead and add one for expect no more tokens. And we don't need to actually process that message. And let's go ahead and log a little info message here. That looks good to me. And maybe we should go ahead, let's go ahead and include a little value here. We'll go ahead and basically mention the number of tokens that we found. All right, that looks good. Now, the next thing we need to do after we've grabbed these tokens, need to let all subscribers know about the counts. Yep. Nice try, Copilot, but no, that is not correct. What we want to go ahead and do here is we're going to create a little object, and we're going to do, that's one idea, Copilot, but I've got a better one. We're going to go ahead and turn this into an immutable dictionary. That way, in the event that one of the receivers of this message wants to modify the content here, it's not going to have any impact on anybody else. And we'll just pass that along to our subscribers. And then at the end down here, we will clear all of our subscribers. There we go. So what we're doing here is when we get this expect no more tokens message, we are done counting. We're going to transform our immutable dictionary to an immutable one. And we're going to deliver that to each of the subscribers in our hash set. And then we are going to clear that set of subscribers at the very end. Seems pretty straightforward. Now, the last thing we need to go ahead and handle is our actual fetch counts message. We'll go ahead and do fetch counts when, actually, we'll go ahead and do this. Fetch counts when, let's see, done counting. All right, that looks good. Yep, that looks good too. Perfect. We have gone ahead and done all the right stuff there. Thank you, Copilot. Otherwise, if we get fetch counts, this means we're not done counting yet. So we're going to go ahead and basically store that subscriber for later and send them a reply back. Looks good to me. And then finally, we need to go ahead and add our default case unhandled. All right, this is pretty much pitch perfect for the CounterActor. I think this matches pretty closely what we have in the actual Bootcamp source code. So that looks good to me. Let's just compile it real quick. Let's see, no errors, good. Now, the next actor we need to implement is our ParserActor. Let's go ahead and do that. We'll also make this actor an untyped actor. Private read-only I logging adapter. Go ahead and do one of these. All right, we got to implement our onReceive method. Let me go ahead and mark this actor as sealed. Let's do that real quick. All right, looks good. And we'll go ahead and do using static. Document commands using static. I think it's counter commands. There we go. All right, that all looks hunky-dory. Now, the next thing we're going to go ahead and do is this ParserActor is going to need to maintain a reference to the counting actor in order to communicate with it. So we'll do CounterActor right here. Looks good. And we'll have this value passed into the ParserActor's constructor. So when the ParserActor is created, one of the arguments we're going to need to pass into props is we're going to need to pass in a reference to the CounterActor. All right, that's totally fine with us. Next thing we're going to also want to define, and I'll do this up here, private const int. We're going to go ahead and call this token batch size. And this is going to basically determine how many tokens we send at a time to the CounterActor. This is an arbitrary value. In theory, if you had a really small file, you could just send all the tokens all at once. But let's say if we were working through a file that was several gigabytes in size, maybe we would go ahead and use some fancy, span logic and go ahead and parse 2 kilobits or 2 megabits or however big it is at a time and extract tokens that way. This is just kind of meant to simulate what some of that real work might look like in the future. Now, I'm not going to accept the suggestion from Copilot here. I'm just going to write my own code. We're going to go ahead and receive a process document command. Process, there we go. Going to open some brackets up here. Now, the next thing I'm going to do is I'm going to go ahead and chunk tokens into buckets of size, token batch size. And what we're going to do here is do a little for each statement. We'll go ahead and do token batch in process.raw text.split. We're going to go ahead and basically just use just spaces for doing tokenization. In a real corpus of text, you might want to use something a bit more sophisticated where you have multiple delineators you can split on. But since we're trying to learn akka.net and not, natural language parsing, this is probably fine. And then we're going to use this new link method that I got added in .NET 8 or 9. Don't exactly remember, but we're going to use it. We're going to go ahead and call it chunk, and we're going to pass in our token batch size here. I will accept that suggestion from GitHub Copilot because that is correct. We're going to go ahead and basically stream to the CounterActor. And then finally, once we reach the end of the line down here, we're going to go ahead and deliver our expect to know more tokens message back to the CounterActor. And then finally, we're going to go ahead and use a little bit of boilerplate right here. We're going to go ahead and basically say any unhandled message we will be funneled to the unhandled message handler down below. So I think both of our actors are in pretty good shape now. Now the next thing we need to do is actually start these actors inside program.cs. So let's go ahead and do this. The first thing I'm going to do, let me go down to the bottom here. I'm just going to keep tacking on to this application. We're going to go ahead and start CounterActor and ParserActor. All right, so I'm going to go ahead and create a brand new CounterActor. That looks good. We're going to pass the CounterActor into our actor system. That looks good. Next, we need to start our ParserActor. Notice that the ParserActor takes the CounterActor as a dependency. It's exactly what you would expect. I'm going to go ahead and start the ParserActor up. Everything looks okay so far. The next thing I need to do is query the CounterActor and wait for word counts. So we're going to create a little promise right here. And this promise will be an iDictionary of type string int. And we'll go ahead and say completion promise equals counteractor.ask iDictionary string int. Normally I don't bother doing typed arguments here, but here we are. And then I'm going to use this little bit of funky syntax here, where I'm going to go ahead and do ref. Sorry, let me go ahead and space this out here. Yeah, ref, that looks good. Cancellation token.none. That looks fine. And let me go ahead and format that real quick so things kind of flow a little bit more nicely. So what's this little funky syntax here? This is a special version of ask where, remember how I mentioned earlier that ask creates a temporary one-time use actor? This allows me to use a little function where I get a reference to that temporary one-time use actor, and I can pass that into this little method here, which will return the message we're going to send to our target actor, the CounterActor here. So this allows me to kind of dependency inject the temporary one-time use actor into my own message. This is useful if you're using messaging patterns, just like the one we're doing here, where there's sort of an explicit actor specified in the message who should get the reply. That's really what this pattern is kind of designed to help support here. All right, so that looks good. We're also not passing in a timeout here. We want to go ahead and give this actor as much time as it needs to complete its tasks. That's fine. If I wanted to specify a timeout, I could do that here, or I could pass in a cancellation token. All right, that all looks good. Now, in order for this to actually run, I need to actually send a document to the ParserActor. So why don't we go ahead and do this? We'll go ahead and do that. And you know what? I'm going to use a raw string so we can do something a little bit beefier maybe. We'll go ahead and do that. Go ahead and do that. Let's break this out into separate lines. Let's see. All right, there we go. Got a couple of repeat words in there, but not too many. All right, and then what we're going to do is we are going to wait for the CounterActor to finish counting. That's exactly right. And then we'll go ahead and log these out to the console. All right, and let me go ahead and just flesh that out a little bit. Okay, so what we're going to do here is we're going to send this document to the ParserActor. ParserActor is going to tokenize it, stream it to the CounterActor. Once the CounterActor has finished counting everything, it will reply back to all of the actors who have sent it a fetch counts message, and it will send them as an immutable dictionary all of the word frequencies. So let's go ahead and run this and see what happens. Okay, here we go. So we see that we have ask, my, tell, learning, friend, R, 2 instances of R. Everything else is only a single instance. This thing with tell here and tell down here, this is another example of maybe where we might want to beef up our tokenization a little bit. Stripping things like punctuation might be a good idea for a more robust version of this in the future. But otherwise, we get the big idea. So with this Unit-0 complete now, we have learned how props works, how an actor system works, how to use ask, how to define messages, how to define actors, and how to design basic messaging protocols. We're going to build upon everything we've learned here in Unit 1. So stay tuned for our video on Unit 1. That'll be the next part of your learning journey with akka.net, and we're going to get a lot deeper into more productionization concerns as part of that. But if you have any questions or comments, feel free to leave them in the comments on this video or on the lessons on the actual Bootcamp webpage itself. You can also chime in on the akka.net Bootcamp Discord as well. So find links to all of that below. Thank you very much for watching. Please don't forget to like and subscribe.